Alright, hello everyone. So next topic in our basic integration review series is how to integrate exponential functions. Now integrating exponential functions are very easy. Well, I should say it like this. Exponential functions with some constants, then it is very easy to integrate. But exponential functions together with some other functions, then it's not that straightforward. Okay, so let's say like that. In exponential functions by themselves only, then they are the easiest to integrate, and on the other hand side, they are the easiest to differentiate also. Okay, so without wasting time, so let's start it. According to rule 7, integral of e to the x is e to the x plus arbitrary constant c. That's easy, right? Okay. Now, but still this video is very important because I'm going to explain a very important thing. Now, how about this exponential function is multiplied by a constant k outside? That means the whole exponential function is multiplied by k, okay? Understand that very well. But not only that, inside this x, so in this exponential function you have x, and that x is also multiplied by a constant a. Now when you have that, what can you do? So let's learn it from an example. Let's try to understand it for each constant, okay, k and a. Let's take a simple example, 2e to the x. Now I don't have a, well, I have a, that's 1, but I have k, I do have k, which is 2. Now there's an important difference between k and a. K is the constant that multiplies the whole function, exponential function, but a is really multiplying the inside part of the exponential function, which is x, like, okay, I like to use the word inside here. Anyway, now how can we handle this 2 here, the constant 2? Well, we all know now it, right? Because it's multiplication between ex and 2 is multiplying the whole function. We can take it out, right? And then integral of e to the x is actually e to the x, so this is 2e to the x plus c, right? Well, okay, good. Now how about if we have a constant a? So let's look at that a. Let's have a, let's say 3. Okay, what can we do about this? Now, according to the rule, what they say is, okay, that k coming outside, but you divide by a. That's what rule says. Now, let's look at that. So, integral of this one is supposed to be 2 e to the 3x, okay, over 3. So what you do for that a is you divide by that a. That is what this rule says. So if I take another example really quickly, 2e to the negative 4x. Why did I choose 2? Let's choose half, a fraction. Okay. Now don't get panic because this is half outside, no problem. That is how we treat that constant. E to the negative 4x divide by negative 4 and plus arbitrary constancy. So that is how you use rule 7. Okay, it's very important that you remember we have to divide by the constant a. This constant a is the constant that is multiplied the x, the inside part of x. Okay, now why is this happening? Again, I have to say, like my last video, we are gonna learn that in future under integration by substitution, but we don't need to use a special technique. We just can remember it right away here as a rule, right? Now before we finish the video, I wanna discuss differentiation. Okay, so let's see, try to understand this. So let's say we want to differentiate e to the 2x. What do we get? If you differentiate e to the 2x, if you differentiate an exponential function, you get the same, right? E to the 2x. But we have to do something about that 2x, right? What can we do? We use chain rule, right? We differentiate 2x and the derivative is 2. So that is the derivative of e to the 2x. Now think in this way. If we want to integrate 2e to the 2x, now tell me, what should you get? what should you get? You should hopefully get e to the 2x plus c, right? As I explained in the previous video, integration and differentiation is like addition and subtraction, or multiplication and division, opposite of each other. Okay, so it's like the control C in your keyboard, like the undo button. Okay, so now I'm gonna undo this differentiation, go back. So if you integrate, that is the process. The undo process is the integration. So if you undo it, if you integrate it, hopefully I should get e to the 2x, of course, plus c. Let's not forget that. Okay, so yeah, so actually if you integrate this without thinking about this two here, okay, we know because of this two will come here. I'm talking about this two, it will come here, e to the 2x. So now see, we get 2 e to the 2x. So now see, we have to divide by 2, right? If we divide by 2, if we take this 2 into consideration, you cancel out, you get e to the 2x. Okay, so in differentiation, when you differentiate, how you deal with this inside constant is you use the chain rule and it appears as multiplication. Okay, in differentiation. Now what happens in integration? In the reverse way, well, the way that you handle that constant inside the function is that you divide by it. Okay, all right, so yeah, that's what I wanted to explain in this rule 7. So yeah, then what can we do now? Well, you can watch my next video to learn your favorite functions, integrating trigonometric functions. I will see you in the next one. Bye bye.